Here we have a SAT math problem. Okay, let's go to the question. Here we have two right triangles. In the figure above, points A, B and D lie on the same line. If AB equals to 18, B equals to 8, D equals to 6, what is the value of sine A? Actually, AD is a single line segment and it is shared by the two right triangle for the hypotenuse. Okay, and also we can consider the given lengths. So AB is 18, B is 8 and D is 6. And here we have a right angle, here we have a right angle. Since I have right angle over here at the vertex E, D is a vertical line segment and B is a horizontal line segment. The same thing we have for this right angle as well. That is BC is a vertical line segment, AC is a horizontal line segment. Since both BE and AC are the horizontal line segments, they must be parallel. Okay, so these two line segments BE and AC are parallel, and then the line segment AD will become transversal. Since AD is a transversal, the lines angle measure over here, angle measure over here are corresponding angles and they must be congruent. That means that they must be equal to each other. Now it's very clear. So angle measure B and angle measure A are equal, and angle measure E, angle measure C are equal. Okay, so the two angle measures of one triangle are equal to the two angle measures of another triangle. By angle similarity postulate, so the two triangles are similar. Okay, now let me write the vertices of the triangle we have over here. That is, let me take the vertex A. What is the corresponding vertex in this right triangle? So that is clearly B. Now let me take the vertex C in this triangle. What is the corresponding vertex in this triangle? So that is E, because both of them are having the right angle E. And the third vertex for this triangle is B, and the third vertex for this triangle is D, and these two triangles are similar. Okay, now let me find the value of sine A in this triangle. So sine A means the value of the trigonometric function sine for the interior angle measure we have at the vertex A. And now let me find the value of the trigonometric function sine for the interior angle measure at the vertex B. Then I'm getting sine B. Already we know that the vertex A and vertex B in these two triangles are corresponding vertices, and also the two triangles are similar. Whenever two triangles are similar, when I find the value of a trigonometric function at the corresponding vertices, they must be equal. So the value of sine A and the value of sine B must be equal, because in these two similar triangles, A and B are the corresponding vertices. So when I find the value of the trigonometric function sine for the interior angle measure at the vertex A and the vertex B, so they will be equal. Okay, now what we can do is we can get the value of sine B. Whatever value we are getting for sine B, the same value can be considered for sine A. So why should I find the value of sine B? Better we can find the value of sine A, because according to the question we have to find the value of sine A. Yes, we can find, but in this triangle, if I want to find sine A, I must be knowing the opposite side, because when I find the value of sine A, I have to consider the interior angle measure of the vertex sine A. The side which is opposite to this interior angle measure is opposite side. Opposite side is unknown. So we know only the hypotenuse 18. But when I go to triangle BED over here, I know that lengths of two legs, 6 and 8. Using these two legs, I'll be able to get the hypotenuse BD. Once I get the hypotenuse BD, I'll be able to get the value of sine B in this triangle. Okay, now let me assume X as a hypotenuse of this triangle BD. So by Pythagorean theorem, we have x square equals to 6 square positive 8 square. That is the square of the hypotenuse is equal to sum of the squares of the lengths of other two sides. Then we get x square equals to 36 positive 64. X square equals to 100. Now to get up this square, we have to take square root on both sides. When you take square root on both sides, usually when we take square root on both sides, we have to consider positive or negative sign for the square root which contains number inside. So we have to consider positive or negative sign for this square root because it contains the number 100 inside. But here x represents the length of hypotenuse. Length of hypotenuse cannot be negative, so we don't have to consider positive or negative sign. We can keep it as it is. Here on the left side, the square root will cancel out. X equals to the value of square root of 100 is just 10. Okay, now I got the length of the hypotenuse over here, that is 10. Okay, now let's get the value of sine B. So sine B equals to, the formula is opposite over hypotenuse. Let me write over here. Okay, so what is the value of, what is the length of opposite side? We find sine B. Sine B means we have to consider the interior angle measure of the vertex B. So the side which is opposite to this interior angle measure is opposite side. So that is 6. And the side which is opposite to the right angle is called hypotenuse, that is 10. So when I simplify this one, I'm getting 3 over 5. That is 2 goes into 6 3 times, or 2 goes into 10 5 times. Okay, now I got the value of sine B, which is 3 over 5. Already we know that sine A equals to sine B. For this sine B, we got the value, that is 3 over 5. We can plug in 3 over 5 over here. Now I got the value of sine A. The value of sine A is 3 over 5, or we can say this is a fraction as decimal, that is 0.6.